Welcome back to the channel. Today, we're diving into the fascinating world of neural networks. Whether you're building a classifier to answer, "Is this product tasty?" or a regressor to predict, "How tasty is it?" Neural networks can be your go-to tool for solving these problems. But here's the catch. Designing, training, and evaluating these models isn't as magical as it might seem. The key lies in smart prompt design, breaking complex tasks into manageable steps, and crafting prompts that guide ChatGPT to generate effective solutions. We'll follow a clear workflow to build and evaluate a neural network. Pre-processing the data, building and training the model, analyzing the results, and testing other approaches. Let's jump in and see how smart prompts can simplify working with neural networks. Right out of the gate, ChatGPT suggests a neural network code that looks pretty solid. Seems like it remembers our earlier experiments. But it's not perfect yet. We need a few tweaks. No need to include all 40 companies. And since we're starting with a classifier, we'll create a clean binary target column first. Let's start pre-processing with a binary target column needed for classification. I asked ChatGPT. Perfect, the yummy column is ready. To handle categorical features like the company column, let's use one-hot encoding from the pandas library. We'll also limit the encoding to companies with at least 10 products, to avoid creating too many features for a small data set. Next, we scale the features. Why? Features like price and number of reviews might range from tens to thousands, while others like flavor range from 0 to 1. Without scaling, the model could give undue weight to larger numerical values. Normalization, which transforms all values to a range of 0, 1, works best here since our features aren't normally distributed. Now, all our features are ready for the classifier. Let's move on to building the neural network classifier. By specifying feed-forward architecture in the prompt, ChatGPT avoids suggesting overly complex networks. The resulting model has just one hidden layer with 16 neurons. Okay for small datasets like ours. With the model trained, ChatGPT helped us evaluate its performance. Let's also look at a confusion matrix. Not bad. But there's always room for comparison. Is this model better than simpler options like SVM or logistic regression? ChatGPT provided code to analyze the results. The confusion matrix and classification report show which classes the model predicts well and where it struggles. This step helps refine the model. By testing multiple models, we ensure we're choosing the best one for our data. Simpler models often perform just as well, if not better, than complex ones. Smart prompt design is the secret to unlocking ChatGPT's potential. By being clear, concise, and iterative in your requests, you can build powerful machine learning pipelines with ease. From pre-processing to model evaluation, you're in control. Don't forget, simpler is often better, and data pre-processing is the foundation of any good model. Thanks for watching, like, subscribe, and let's continue exploring the amazing world of ML together. See you next time.